Okay, let's work this example. We are told a ball was dropped from a height of 100 meters. What is its initial velocity? Again, here we pay attention to the words. Dropped. That tells us that the initial velocity is 0. What is its velocity 2.5 seconds after being dropped? So we are going to use the equation for the velocity. Vf is Vi plus At. Velocity at constant acceleration. Remember our acceleration, I'm going to use the 10 in this case, is minus 10 meters per second squared. So in this case, that's going to be 0 plus minus 10 meters per second squared times 2.5 seconds. So in this case, that comes out to be minus 25 meters per second. So the magnitude of that velocity is 25 meters per second. Its direction is downwards because we have a negative sign here. What can you say about the final velocity? Without calculating it, nothing. But let's calculate it. It is dropped since we know the height that it's going to fall. We know the height is 100 meters, so we can find the final velocity. Okay, we don't know the time here. One equation, if you recall the kinematics equations, the last equation here does not have time in it. So it has Vf squared minus Vi squared is equal to A times displacement. So we'll write that down and use it. So Vf squared minus Vi squared is equal to AD. So in this case, Vf is what we are looking for. Vi is 0. Twice A is minus 10 meters per second squared. D is minus 100 meters. Remember the minus since it's downwards. So my Vf is just square root of 1,000 meters per second. I'm not going to go through the calculation here, the numerical calculation, but you get the idea. With a minus sign. Remember the answers are square root. The possible answers are the negative and the positive, but only the negative answer is correct because we know it's moving down. So we are using physics, our knowledge there, to determine the direction.